So this is chapter 7, the language of chemistry. The first part has 4 rules, 1 video per rule. And then the second part of this chapter has the same 4 rules, except you're doing something a little bit different, kind of working backwards. So a little bit of background information. You first need to know the significance of a chemical formula. So a chemical formula is going to be element symbols and potentially numbers ranging from 1 to whatever that are called subscripts. So in this case, we have C8H18 would be how you could read that. And the 8 means that there are 8 carbon molecules in this atom. So the subscript goes with whatever element it comes after. And on this side, we have an 18 after the H, so there's 18 hydrogen atoms in this molecule. So you need to start understanding the significance of both the chemical symbols as well as the subscripts. And remember, a chemical symbol is either 1 or 2 letters, the first of which is always capitalized. If there are 2 letters, the second must be lowercase. And the subscripts must be written smaller in size and kind of put below the line of your paper. If I give you a subscript, for example, C8H18, you cannot change these. So if you are given a subscript from the board or on a typed worksheet, that is the correct subscript. You cannot erase it, change it, white it out, cross it out. You have to use what's given to you. Okay, let's look at this equation. So in this case, we would say Al2SO4 3. First, what elements are present? We have Al, aluminum. Remember, it's important to note that if I want to give a capital I, I'll put a top and a bottom on it. If you just see a line, that's a lowercase l. So Al is aluminum. We also have capital S, sulfur, and capital O, oxygen. This is also why it's important to make sure you're capitalizing and lowercasing letters appropriately. So we see subscripts, but we also see parentheses. So if you have parentheses, any subscript outside to the end of the parenthesis must be distributed to everything inside the parenthesis and must be distributed by multiplication. But you only go to the front parenthesis. So this 3 would have to be distributed to the O and to the S, and that's it. This parenthesis is kind of like the wall that stops it. In this case, let me get my pen. We have a 3 on the outside, so we're going to multiply it to the S, to the O, and then we're also going to multiply it to the S. So if we were to make a list, we've got aluminum, sulfur, and oxygen. We have 2 aluminum, and then we have 3 times, if there's not a subscript, it's assumed it's a 1. We just don't write them. So 3 times 1 gives us 3 sulfurs total, and 3 times 4 gives us 12 oxygens total. So in this compound, we have 2 aluminum atoms, 3 sulfur atoms, and 12 oxygen atoms. So once again, just make sure if you have something outside of the parentheses at the end, you distribute it by multiplication to everything inside the parentheses, and the front parenthesis stops you. You don't want to go forward. And if there's not a subscript, it's assumed it's a 1. We never have zeros. Okay, looking at your periodic table, you're going to need to write these down. So get your periodic table out, and these are charges which actually come into play in the second half of this chapter, but I'm just going to give them to you now. So the whole row, HLINA, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, all have a charge of +1. So write +1 at the top. You don't need to know about it now, but just write it down. The second family, beryllium down to radium, have a +2. I'm going to skip over the transition elements right now. I'm going to go to group 13, so boron, aluminum, and so forth down have a +3. Carbon, silicon, germanium, and down have a +4. And then we go backwards. So group 15, nitrogen, phosphorus, and so forth can be a plus or minus 3. You'll see why in a minute. Oxygen, sulfur, and down have a -2 charge. Fluorine, chlorine, bromine, iodine, and acetylene have a -1 charge. And then the noble gases, helium, neon, argon, krypton, xenon, and radon, no charge. Okay, let's look back at the transition elements, which is this middle part of our periodic table. So if you recall back to valence electrons in group 4, we said that the number of valence electrons vary. The same thing is true with charges. So now we're going to actually have to go into a specific element and write the charge. So starting with titanium, +2 for titanium or +4. So this is just for titanium. So you may want to actually write it in the box as well. Just make sure you can read it. Okay, and then going over to chromium. Chromium can also be a +2 or a +3. Manganese, +2 or +4. Iron, +2 or +3. Cobalt, +2 or +3. Nickel, +2 or +4. Copper, +1 or +2. Zinc, we're just going to give it a +2. Going down to silver, +1. Going over to cadmium, +2. Going down to mercury, +1 or +2. Going over to tin, it can be a +4, but it can also be a +2. So I just wrote the +4 again, so you don't forget. Lead can also be a +4 or a +2. So I just wrote the +4 again, because that's for everything in this group. And then that's it for charges. So make sure you have all of those written down because you're going to need them later in the chapter. And then once again, the noble gases do not have a charge. They're non-reactive. Okay, the other thing you need to know for this chapter, which once again, you don't have to know right now, but you're going to need to know eventually, diatomic elements. So diatomic elements are elements that are naturally found in pairs, kind of like twins. So when you find these elements in nature, they're always connected to another atom. So di meaning two, atomic meaning atom. So whenever you write these elements by themselves, just that symbol, you have to include a subscript of 2. Once again, we'll talk more about this when the time comes. So I want you to highlight these yellow, or whatever color you have. So we've got hydrogen, and then the rest are on this side of the periodic table: nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There's 7 total. Hydrogen 1, 2, 3, 4, 5, 6, 7, and these are our diatomic elements. So if you see an H by itself, or an O by itself, or Br by itself, it has to get a subscript of 2. We'll talk more about that later. Okay, now actually getting into section 1, naming compounds. So I'm going to give you the chemical formula, and you're going to give me the English language. And there are 4 different rules. We'll do them in chunks. So the first rule is for binary compounds. Bi means 2. So these are compounds that are made of 2 elements. And the rule is you say the name of the first element like you find it on the periodic table. You say the name of the second element from the periodic table, except you change the second element's ending to IDE. You add that suffix. And spelling does count here. You have your periodic table in front of you, use it. So say the name of the first element, say the name of the second element, except you change that element's ending to IDE. So let's do some examples. So I've got ALN. This is also where it's important to know your elements. Capital A, lowercase l, and then capital N. 2 elements, aluminum and nitrogen. So the rule is to say the name of the first element, aluminum, and then I'm going to say the name of the second element, nitrogen, except I'm going to change the ending of nitrogen to IDE. So it becomes aluminum nitride, not nitrogide, not nitrogenide. I cut off the ending and put the IDE, so aluminum nitride. And this will become easier the more you do. So it may sound weird or you may cut it wrong. You'll get used to it. Try another one. And I will tell you, it does not matter if there's a subscript. Ignore it. Just focus on the elements. So I've got lithium and I've got oxygen. So that becomes lithium oxide. Oxygen became oxide. Na2S, once again, ignore the subscript. Sodium and sulfur become sodium sulfide. Okay, try this one. CaF2. Once again, you ignore the subscript. Ca is calcium. F is fluorine. It becomes calcium fluoride. Make sure you're spelling fluoride right, as well as all of them. Okay, I'm going to put these up here. Try these ones. Pause your video. All right, if you're not ready, pause it. Got K2SE, ignoring the subscript. K is potassium. Se is selenide. Oh, I gave it away. Selenium becomes potassium selenide. What about this one? CaS. Ca, calcium. S, sulfur. It becomes calcium sulfide. Okay, this one, I'm ignoring the subscripts. I've got Mg and P. Try that one. So Mg, magnesium. P, phosphorus. It becomes magnesium phosphide. Okay, last one. BAI. And notice I have a top and the bottom on the I. That is how you can tell the I from the lowercase l. So ignoring the subscript, I've got Ba and I. So Ba is barium. I is iodine. It becomes barium iodide. So that is how you name binary compounds. Compounds made of two elements. Say the name of the first element. Say the name of the second element with the suffix IDE. Ignore subscripts.